Welcome to all. I, Dr. Chitra Singh, Professor, Department of Mathematics, Rabindranath Tagore University, Bhopal. Today we are discuss to the course Calculus and Differential Equation, which topic is tracing of the curve. The objective of the tracing of curve is to understand the trace the curve. How students trace the curve. Tracing of curve. To find the approximate shape of a curve represented by Cartesian equation, the following process are as follows. Means that how you trace the curve in Cartesian equation. If you are given to Cartesian equation and says that you draw a curve, so you opt the process. First, find symmetry. Second, nature of the origin and the tangent at origin. Third, the point of intersection of the curve with coordinate axis. Fourth, asymptotes of the curve. Fifth, the curve solved for y-axis or x-axis. Sixth, the region in the plane where the curve does not exist. And seventh is special points. First, how to find symmetry? You find symmetry and you draw a symmetry of the curve. So firstly, you see that the curve is symmetric about x-axis and the curve is symmetric about y-axis. So you check the curve is symmetric in x-axis and the curve is symmetric in y-axis. For example, we get equation y square equals to 4x. So you check in this process. First you see the power of x is even or power of y is even. If your power of y is even, so then your curve is symmetric about x-axis. Symmetric means the face of both sides of the curve is on the x-axis. If your face is curved on the x-axis, then you say that the curve is symmetric about x-axis. If in the equation of the given curve the powers of x are all even, so then curve is symmetrical about the power of x is even, then curve is symmetrical about y-axis. In this figure we say that the equation is x square equals to 4ay. Then we see the face of both sides of a curve is y-axis. So then the curve is symmetric about y-axis. Nature of the origin and the tangent at origin. So first you find the nature of the origin. In this process we substitute x equals to 0, y equals to 0, then we get equals to 0. Your function is 0. f0 0, then we get function is 0. So then we say that curve is passed through the origin because the curve intersect at the point at origin. And second, if the curve pass through the origin, the equation to the tangent at the origin are obtained by equating to 0 the terms of lowest degree in the curve. We substitute the lowest degree of term is 0, so then we see that the function is 0. So then we check the curve will pass through origin. In this figure we see that their curve tangent is on y-axis because the curve this tangent intersect on the curve at 0 0. It intersect means this is a tangent. This is passes through the tangent. Y-axis is tangent on this curve. The point of intersection of the curve with coordinate axis. In this point we check that the curve intersect at axis, at x-axis and y-axis at this point. So x square plus y square equals to a square. This is the equation of the curve. In this equation we substitute x equals to 0. Then we get now y equals to plus minus a. At that means that this point is y is a in positive direction, y is minus a at negative direction and x equals to 0. This point cut the y-axis at 0 a. If we substitute y equals to 0 in this equation x square plus y square equals to ax square, then we get now x equals to plus minus a. So then we say that this point plus minus a intersect the x axis at a 0. At that point x is a and y is 0. and that point x is minus a and y is 0. So, this this intersect the x axis at a0 and minus a0. This is find the intersection of the curve with coordinate axis. Asymptotes of the curve. A straight line at a finite distance from the origin to which a tangent to a curve as the distance from the origin of contact tends to finite is called asymptotes. Asymptotes means the straight line of the curve which tangent on the curve at finite. It cuts on the it touch on the curve at infinite distance. This is the asymptotes of the curve. Asymptotes means that a straight line which tangent of the curve at infinite is called asymptotes of the curve. So, you also check the asymptotes of the curve. If line is touch the curve on infinite, this is called asymptotes of the curve. Solve for y or x. If the curve is symmetrical about x axis or there is symmetry in opposite quadrants, then it is sufficient to consider only the positive values of y. It means that curve is symmetrical about x axis, and you check the curve equation is solved for y and you check the equation is solved for x. So, that is that you solve the equation for x and y. The region in the plane where the curve does not exist. In this case, find out those values of lying in a range values of x between a and b for which y is imaginary. This implies that the curve does not exist in the region bounded by the line x equals to a and x equals to b. Means that your y axis is imaginary, and you find the values in x and y is imaginary points or negative points. Then this we say that the curve in that region where the curve does not exist. Special points means these points which are defined on the curve with maxima, minima, concavity and convexity. If your you unable to draw a curve on these points such as symmetry, origin of the tangent and intersection points, asymptotes, solve for y on x and x on y. So, then if you are unable to draw the curve in this point, so then you take special points. Special points are not required on the simple curve, and if there is no need to find a special points, but any special case if you are unable to draw a curve, then you take special points. Students, you are outcome of this you are able to trace the curve, and you understand easily to how to trace the curve. Thanks.